polynomial is a very important expression in maths, and we need to know all the terms that define it. So firstly, a polynomial is an expression, or algebraic expression, which is composed of variables, constants, and exponents. So before I continue with this definition, what do I exactly mean by variables? Such as, for instance, x, or y, or z, or any other letter from the alphabet that you'd want to choose, or even A, B, C, whatever you like. And constants are numbers such as 1, 2, 3, or a decimal number like 0.5, etc., as well as exponents. And exponents would be such as for instance 5 in x to the power of 5. And these variables, constants, and exponents, they are combined using mathematical operations such as addition and subtraction. An example of a polynomial would be an expression such as this, where 5 is said to be the coefficient, x will be the variable, and 2 will be the exponent. This polynomial is one term only, and we call it a monomial. Now I can add to this term another polynomial, such as 2y, and this will be known as binomial. And now I will add another term to this polynomial by using a subtraction operator with a term which is called constant. You'll notice that it does not have a variable next to it, so it's not a coefficient, it's a constant. And this polynomial, which has 3 terms, is now called a trinomial. And so you'll notice that we can continue on adding terms to this polynomial, and then it'll be called quadrinomial, and so on. Now I want to give you some examples of what cannot be a polynomial. This term with a negative exponent is not a polynomial. A polynomial cannot have negative exponents. Also, 3x y to the negative 2 has also negative exponents, so this is not a polynomial. 1 over x, or something like 3 over x plus 2, is also not a polynomial. Root x, or x to the 3 on 2, is also not a polynomial because no fractional exponents allowed. So let's see if you can actually recognize polynomials. So you saw that 1 over x, or 3 over x plus 2, is not a polynomial because we couldn't divide by a variable. But what we can do is divide it by a constant. So x over 2 is a polynomial. X plus 2 over 3 is also a polynomial. That's allowed. And so is 3x over 8. That's allowed too. Minus 6y squared is allowed. Fractions such as 7 over 9x is allowed. We can have 3x, y, and z. That's allowed. We can have 3x, y squared, z, and we can also have 0.1 x z. That means a decimal. We are allowed to have a decimal as well. We are allowed to have 0.5 on its own, because that is a constant, such as a fraction 2 on 3. We can have that too. Now, mostly we can have root 2 because that is a decimal. And also it is a constant, such as 1.4142, etc. So these are all allowed. And lastly, I want to talk about the degree of a polynomial, which is defined as the highest exponent of a term within a polynomial. For example, a polynomial with a variable x, which is equal to, say for instance, 6x3 plus 4x squared plus 3x plus 1, its degree will be 3 because 3 is the highest exponent. And a polynomial such as this one, the degree will be 2, as this is the highest exponent or the highest power of that polynomial. What about 3x plus 1? The highest power in here is going to be 1, so the degree will be 1. And this tricky one, where the polynomial is just a constant, obviously the degree will be 0, as this would be the same thing as writing 6x to the exponent 0. And one more tricky one, we look at the highest power, and the highest power here is 4, so it'll be degree 4. And you'll notice by this that it is common for us to write polynomials with the highest degree as the first term, followed by lower powers. Knowing these definitions is critical in being able to manipulate polynomials algebraically, as well as understanding polynomial functions, such as rational functions and other functions in which polynomials are used.